Right, here we go with another Formula One, and this time it's formula with letters. Now, it doesn't matter who you are. Um, it's a bit scary, this one, because this is touching on algebra. That's what it is, formula with letters. We're using letters to create formulas, or we have been given a formula with a load of letters in. Now, let's go back to our bananas. Um, so we've got, a, let's have a look, 6 bananas at, um, say, £3. The same thing, £3 each. Right. Now, it may be that the bananas um, we shall call B for bananas, and this will be the cost. So what we need to do is we need to multiply the bananas by the cost. So it's B times C. Yeah. So it doesn't matter what the cost is or how many bananas we have at the moment. It's just going to be B times C. C is the cost. Yeah. B, but bananas. Well, that's obvious. Yeah. So it's just B times C. Now, when we have two letters together, two letters, or numbers and letters together, we don't use the multiply sign. Now, the reason we don't use the multiply sign is I don't know, but I think it because it might look like an X. And if one of our letters in the formula is an X, we might get confused. We might have, X, X, X. What is that? X times X times X? Or is this X times X? We don't know, so it's too complicated. So, excuse me. So we don't use the X. So what we do, we take our B and C and we just write it BC. Yeah? B times C. An invisible little multiplier. Yeah? Now, so how do we work this out? Using this. So we know that the value of B is 6. So we put 6 in place of the B. And the value of C is 3. So we put 3 in place of the C. And we just multiply the 3 together. We've got to put a multiplier in there, otherwise it looks like 63 and 18. So we're using letters, yeah? It's very strange, but we need this when we're doing areas and volumes and things like this. It's all going to be letters. Now, um, so let's have a look at something. Um, so let's have a look at this. So if we've got S equals pi, ooh, is that new? That's called pi. That's a Greek letter pi. Don't worry about what it is at the moment. It just looks like two little things with a hat on the top. It's called pi. Pi, um, pi d. Yeah, there's one. I might as well make it the proper one, haven't I? C. Because that is a proper formula that we'll come across later on. So if we're going to work out what the value of C is, we need to know what pi is, and we need to know what d is, and we multiply the two together. So if we say that pi for this exercise equals 3 and d equals 4, Then in order to work this out, we've got C equals 3 times 4, which equals 12. So all you're doing is you put the 3 in place of the pi, and you put the 4 in place of the d, and you multiply the two together. Alright, hopefully that's all we need to do. Let's have a look at this one. 2a over c. Yeah, what's that? Equals something, yeah? So we need to know the values of a. So a we'll say equals 10 and c equals 4. Yeah. So now we go back to an earlier lesson, BIDMAS, so that we do things in the right order. So this becomes on the top 2 times whatever a is, which is 10. And then underneath, whatever c is, in this case it's 4. So this becomes 20 divided by 4, which equals 5. All sorts of things. Now remember, there's a sign we're going to need to know, I think in a minute. X, there's an x, a curly x, so it doesn't get mixed up with a multiply. If I do x squared, so this is squared. So squared means something times itself. Something times itself. Now, x equals 4. So what is x squared? So that will be 4 squared, because x is 4, so you put 4 in place of the letter. Now 4 squared means 4 times itself, which is 4 times 4, which is 16. How's about that? Let's have a look for some examples, see how complicated they get. Don't forget, as always, pause, have a go, see if we get the answer to these. Now, oh look, we've got a squared straight away there. Right, so this is going to be 6 times a times b squared. So it's 6 times a is 4 times b squared, which is 7 squared. Now BIDMAS tells us to do the square bits before we do all the multiplying. So 7 times 7, 7 times 7 equals 49. So this now becomes 6 times 4 times 49. 6 times 4 times 49, which is 1.76. 1176. This one, 4a over b, when a is 9 and b is 12. So 4a is 4 times, what is a? 9, divided by 12, because b is 12. 4 nines are 36, so 36 divided by 12 is 3. Well, this one looks more complicated. A teacher is organising a school trip. The formula is S equals C divided by 20. Whew. Is used to work out the number of staff needed on the trip. So S represents the number of staff. C is the number of children. And if 80 children are on the trip, how many staff are needed? That's all right, isn't it? So we've got to find the staff. So the staff equals supposed to be an S, sorry. Children, 80 children. 80 divided by 20, which equals 4 staff. Oh, such a long question for an easy calculation. Just 80 divided by 20. If there was a different number of children on there, you'd have a different number divided by 20. So, the area of a trapezium. What's a trapezium? A trapezium looks like that. That's a trapezium. We'll get onto that later on with shapes. The area of trapezium is given by the length of the base. Well, that's the base. Hang on, let's highlight. That's the base. Plus the length of the top multiplied by half of the height. Whoa, that's so it's complicated. Right. So A is the area. So we've got A is the area. Write this as a formula where A is the area and A is the top, B is the base, and H is the height. So let's just pick this out bit by bit. The area of a trapezium is given by the length of the base plus B is base plus the length of the top plus the length of the top. The top is A, B plus A, multiplied by half of the height. So we're going to multiply these, so I'm going to do that, multiplied by half of the height. Now, you'll see when I've got the brackets, there is no multiply sign there. You don't need it, yeah? There's no multiply between the half and the height either. So you don't have to write B plus A times half times height because you don't need to put the multiply signs in. So it's just B plus A times half of the height. What is the area of the trapezium? Oh, we had to get this right, otherwise we can't do this bit. With a base length of 13, top length of 5 and a height of 6. Okay, so the area, I'm going to write the formula out so we know. Always do this. If I've got a formula, even if it's given to you, given to me, I'll always write it out because it gives you a bit of time to think what's going on. So the base is 13, so the area will be equal to 13 plus the top, which is 5, times half times 6, because that's the height. Well, 3 plus 5 is 18, times half of 6 is 3. 3 18s are 54 centimetres squared. Oh, this is a step up, this one, isn't it? Aki uses the formula below to work out how many fence posts he needs. N equals P over 8 plus 5. N's the number of fences he posts, P's the panels, and the numbers are the numbers. Aki's front garden will have 112 panels. Wow, that's some kind of garden. Yeah, so we need to work out how many posts. So N equals panels, 112 divided by 8 plus 5. Now you must do the divide bit before the plus. So I'll do that, 112 divided by 8, which is 14. So that equals 14 plus 5, which equals 19 posts. And the last one here is the formula on the right, 10n plus 5, is used to find the cost of hiring a bike, including the deposit. You can see that the deposit is going to be the £5 or whatever it might be. Jill wants to hire 4 bikes for 5 hours. How much will this cost? Now this formula is for 1 bike. Right. Hiring 1 bike. So this is the number of hours. Don't get confused about that's not the number of bikes, that's the number of hours. So we've got 10n plus 5. This is for 1 bike. So the number of hours is 5. So this is going to be 10 times 5 plus the 5, which equals 55. So that's 55 for one bike. Now we've got 4 bikes, so we just need to do 55 times 4. So 55 times 4 is equal to, where's the cursor gone, £220. Yeah. So that was a bit of thinking, because I would have thought that was the number of bikes plus a £5 deposit or something, but no, this is including a deposit. Okay, so that's formulas with letters. So this is a bit tricky, this old one. So next one, something to do with money next time. That got to be easier. Yeah, so I'll see you in the next one.